Dear students, earlier we have discussed that a particle remains at rest or moves with a constant velocity if the net force acting on it is zero. In this case, the momentum also remains the constant. This is an example of very important law of physics known as the principle of conservation of momentum or linear momentum. Before explaining this law, we will explain some terms. Suppose we have two particles A and B. We call the group of the two particles a system of particles. Now, particle A and B belongs to the system. Any other particle is external to it. The force exerted by A on B and that exerted by B on A are called internal forces. Any force on A or B by an external particle other than A and B is called an external forces. So the law states that in absence of an external force, the total momentum of the system remains constant. So this point should be clear to you that the internal forces cannot change the linear momentum of the system. Internal forces can change the momenta of different particles in the system, but not the total momentum of the system. If the momentum of one particle is increased, that of some other particle must decrease to keep the total momentum of the system constant. So you might have understood the system. If I say the one class, suppose a class 10th has 42 students, so we can call it as it is class 2, 10, class 10th is a system of 42 particles. Now we can derive this law of conservation of linear momentum from Newton's third law. You know, if the two particles A and B having mass m1 and m2 and the initial velocity u1 and u2 before collision and v1 and v2 after collision. According to Newton's third law of motion, FAB is equal to minus FBA. FAB means force acting on body A by body B, and FBA means force acting on body B by A. So you know the force is rate of change of momentum. So in this way, finally you will get m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. It means the total momentum before collision is equal to total momentum after collision. This proves the law of conservation of momentum. Now there are so many examples. I will explain only with the help of two examples. See the figure. When a man jumps out of a boat to the shore, the boat slightly moves away from the shore. The reason is initially the total momentum of the boat and man system is zero. As the man jumps from the boat to the shore, he gains a momentum in the forward direction. So to conserve the momentum, the boat also gains an equal momentum in the opposite direction. Therefore, the boat slightly moves backward. Now, the another is, while firing a bullet, the gun should be held tight to the soldier. The recoiling velocity is the velocity by which the gun moves backward. So the recoiling gun can hurt the soldier. If the gun is held tightly against the soldier, then the body and the gun together will constitute a system. So the total mass becomes large and the recoil velocity becomes small. So this is all about the second chapter, force and laws of motion, and you will discuss in detail while you are attend the live classes. All the doubts will be taken there. Thank you and have a nice day. Dear students,